Let's see. Let's solve. Let's do bit by bit. Okay, I'm gonna go ahead and not copy the original, but let's distribute. Yeah, double check my math. Also, 2x minus 8. Okay, and then I recommend you solve the inequality with the x being on the left side. So subtract both sides by x, 2x. Oh, at the same time, subtract both sides by 31. 31. So cancel. You're left with negative 39 and 14 on this side. Wow, the teacher really wanted to, yeah. Oh no, I'm sorry, 13. Good. I thought it's not going to be divisible. 13x. Okay, good. Then divide both sides by 13. I'm trying to squeeze this in so I have space on this side here. So less than negative, what is that, 3? Yes, negative 3. Okay, and we'll wait on that. We'll graph it together with this one. And then you have to write your final answer. Okay, and then this one, add both sides by 3. Negative 2x is left. Less than, no, equals 2 here. Okay, wow. Yeah, your teacher really want to make sure you really know it. No bar here, 8. Okay, divide both sides by negative. It will flip. Negative 2 and negative 2. You flip the arrow with the inequality. Greater than 4, negative 4. Okay, here we go. We're going to have to interpret the answer by graphing with the word or. So this is a big deal here. Or. Well, let's see. So I recommend you graph them and with the 0 being the center. 0, 0. But we're not going to probably start there. Okay, first one, we're going to graph the x less than or equals to negative 3. So 1, 2, 3. Make sure they're like the same, like negative 3, negative 3 here. So negative 3 here. So if I graph it, it will look like this. Oh yeah, don't forget, like the easy way, if you have the variable x, y, or z on the left side, you can point the arrow, shade the graph in the exact same direction. Like you see it right there. Point. Yeah, you can only do that if the x is or the whatever that you're solving for it's on the left side of the inequality. So now for this one, negative 4. So it's negative 4. Wow. Yeah, here it is. This is where if it's not overlap, it's easy, but it's gonna go overlap. So negative 4 is like right here. Okay, fine, like right there. Negative 4, and it's open dot here, and it goes over like this. Now, okay, I want to double check this. I'll even Google it to show you. Okay. Yeah, this is actually like way back concept, but it's when you learn this stuff for the first time. Okay, let me think here carefully. When it is or, now this is like, it may be ironic, right? When it is or, you have to write all the answers that you can actually find when they're actually together, overlapping. Let me see if I don't know how to phrase that perfectly. The answer should be everything that you see except negative 4. Say the overlap here, the overlap in between, by the way, negative 3.4, negative 3.1, negative overlap there until it reaches negative 4. You don't include the answer in between. Like you might think, hey, the answer should be 4 and negative 3. Yes, if this is and. There you go. So there's something about that. Or means, I know it's kind of weird. Or means everything. But if there's a breakage, you don't include that. The breakage is actually negative 4. So the final answer looks like this. They actually teach you to graph the final answer below it. Let me show it to you right now. Like everything is aligned the same way. Then you can write the answer over here. But when they teach you this for the first time, it's something like this. But I'll double check this because I haven't done this for a long time. The math is fine. The concept with the or. So it will look like this. Everything together, except when there's a gap, you cannot include that. So there's a gap at negative 4. So like an open dot here. Imagine open dot right there and negative 4. But everything else will be included Here it is, final answer. Pretty sure, but I'll check it. I'll check it in like hopefully right away. But I want to do more. So if you were to graph this, it would be 4. You don't have to be like marking everything. You know, you're pretty advanced now. Like if you were doing this like back 2 years ago, you have to mark like -1, 0, all that. In college, you just do this. The main number that you need in the end is just 4. Had there been like 2 numbers, then you'll be doing that. I'm making this up. Like I'm -1, then you do that. But everything else you don't. Open dot, close dot, doesn't matter. Maybe this is the next one. Okay, this should be the answer for 1 with the or. If it were an and one more time, the and would have been this little gap here. It would be like between -4 and 3 where they overlap. Yeah, the and will be where they overlap. I know it's ironic, like I said, right? And should be like everything, right? No, it's actually or. I know it's like that's why I always get like confused when I was learning this also. So the and, here we go. We'll do the and right now, and then we'll check. Okay, so I think that's done. Yeah, double check my math. At least numerically, I think everything's good. Flip the arrow. Yeah. Okay, now let's do this one. Add both side by 7. Now I want the variable on the left side, so I'm gonna force it here. Subtract both side by 8. It'll be a negative, but it's fine. I'll flip the arrow later. So I'll do all of that. So let's see what happens here. So 0, that cancel. You'll just left with 5 on this side. This cancel. You're left with -x on this side. 7x minus 8x. Yes, and then you divide both sides by -1 or multiply. It doesn't matter. But everyone does the dividing. When you divide or multiply by negative, you flip the arrow. So it becomes a -5 here. Check on the other side. Yeah, everything over there. Negative. Yeah, so it'll be -3. Yeah, I'm looking back at number 1. At 13 there. Negative divided by positive is negative. Yeah, so I want to make sure. This one is divided by negative, so you gain a negative differently. Okay. Okay, we'll put that on hold. We'll come back and we'll graph it. So 3x minus 3 plus 8 less than 11. Okay. Be patient. Just combine like terms because you can right here. Plus 5 less than 11. Okay. Yeah. Subtract both sides by 5. So you're left with 3x less than 6. Okay. Then divide both sides by 3. So x is less than 2. Okay, now we're going to grab this on top of each other and then evaluate, right? That's that's the way they always do it. Earlier on when you were learning and or concept, graphing on a line number. Okay, so the first one, I forgot. Do the 0 thing. You may need a little longer. Always do the center being 0 for that one, and then even this one, I'll even prep it ahead of time. Okay. 0, 0 here. Okay, I'll grab this first. X greater than -5. So here it is. Let's say -5 is right there, and it's open dot here. No shade. That. Okay, and then x less than 2. Let's say 2 is here. So open dot again also. Yes. Open dot for both. So you grab and go this way. It's compound because you got 2 in one, two graphs, and then evaluate when they're actually together. So here it is for the final graph. Oh yeah, the final answer is here. There. This one, 0 align also, 0. And then here it is, the end, where they intersect. The ends where they intersect. There you go. Yep, they intersect here and here. You see it? Where they intersect. So that's, okay, I think I got this correct, all of it, because I now recall the word and being in intersect. Therefore, everything, the or will be everything else. You see it? Can you imagine what I'm saying? And is for intersect, for sure. This one I do remember vividly. But therefore, the only thing you got left is or. Or is everything else. That means it's not the intersect. So here it is. So you're gonna open dot both of them, and then where they overlap is the answer. So the answer is going to be the graph looks like this from -5 to 2. So you don't need the 0 anymore. That's just the placeholder for aligning the graph. Like so, here's your final graph if you want to show it. Oh, open dot, both, too. Okay, I'm pretty sure, but we'll come back and check on that. But I'm sure now,
It
like
also asks
99.
for interval notation.
Oh, they want, yes, okay, I see. There's uh, you got the final graph and then write your answer in as an inequality. And okay, got it. Okay, we'll do it right now. I see. So the graph is done, and we're gonna do inequality and interval notation. Wow, your teacher really going all out. Okay, easy. The way you do this is like this. If you have an or, you split them with the union. So let me see which one first. The smaller one normally is written first, so it's gonna be x less than -3. Now I think some people actually will write or in place of the union. The or is the u up. It's actually not. It's more like this. If you wonder, it's like a wide u, but they always call it u, a union. The and, it looks like that. And will be a flip upside down. Look like an a, but no more like that. So this should be it right here. I'll even check on this later on, but I'm pretty confident, like 99% sure. Oh, 99 here. The graph is like 99.9%. 4. Okay, so that's done. It's split. When you have an or one, you always split them. But when an and, you always write it as compressed form. It looks like this. Oh yeah, I'm sorry. The interval notation, -infinity all the way to -3, and union again, and then -4 to positive infinity. Are you okay with this by looking at the arrow? You remember this, right? Yeah. Had there been a bar here, I make this up. If there's a bar here, then you bracket this here.
Yeah.
Yeah. So, but this one, they're all. Oh, there is a bar. Sorry, dude. Sorry. Wait, where is the bar? Where is the bar here? At -3.
It's on the negative.
-3. So yes. Sorry, you got to put that bar there. Let me go back. Yes, there's a bar right here. Yes, there's a bar right here. -3. So you got to bracket that. Sorry. Yep. So this is it. Oh, yeah. But anyway, it's bracket. Bracket that and bar here. Okay, good. And the 4 is open dot. Yes, no bar. Yeah, looks good. Okay, for the one that in between, like two numbers, open dot or closed dot, doesn't matter. You write it like this. I think you might remember the bigger one here, the smaller one here, but the arrow must point to the left, both of them, like this. And they're both open. So had this been shaded here, then you put a bar here, but it's not. I hope, keep that in mind. This is how you would write it notation wise, like that. Yeah. Okay, and then is that it? Okay, and then the interval notation. It looks like a coordinate, but it's between -5 and 2. It looks like x comma y, but it's not. You have like 0 in between, -4, and all the numbers in between. There you go. Done.
Would the 5 be the
smaller
like
one.
greater? Would it be the other way?
No. Here's how they do it. The format for the intersect, it's always like this. It goes like this. You always have. Sometimes you have a bar with or without the bar. X or Y, doesn't matter. It depends. X would be normally like if you do like calculus or pre-cal, it's the domain. So you're gonna write with the X. Sometimes if you do range, you write with the Y. But right now it's all about X. So the format, again, you can have a less than, you cannot have greater than. First of all, you cannot have. If you do, you have to flip it back. Yeah. If sometime when you work on the problem, I don't think it will happen here. When you work on the problem, it's all both facing automatically greater than. You got to flip the whole thing back. But anyway, if you do this, it'll be the small and large. Always. This is the format for intersect every single time. If you wonder for the intersect. Or and. Oh, yeah, we're talking about the term of and, but it's related to intersect. And the symbol looks like this. There you go. Now, where do you use a symbol? You don't for this one, but you could. Do you want to see it? But it's awkward. You never do it for when you have an intersect. You prefer that, but there's a way you can use this, but you don't need to do it. Anyway, since you don't even actually mention it, you don't have to worry. But if you can, let me show you right now. You want to know, it's going to look like this: x greater than negative, no bar. If you wanted to do the u upside down, it will be this, and then x less than 2, something like that. There you go. But don't do it. Yeah, so it's like that. Or negative, -5 with the and. And by the way, if you do and, you can put this first or you put that last. It doesn't matter. You can flip it. What I mean is I put over here and then put over there. It doesn't matter. But don't do it because this is like 99% of the time for the and or intersect. Okay.
All right.
Okay. Keep that in mind. Okay. So this is the format, but I'll erase it because I may need space for that. I hope you already copied that down, right? Okay.
Yeah.
But I'll come back and check on these for sure. But I'm like 99.9% sure. Okay. This one. Solve the system. Okay. All right. This one, it's easy if both are already wide, like y is by itself solved. Y is already is solved. All you do is send y equals y is y. You equate these two together. So I hope you're okay. So y equals y. Therefore, this equals to each other, and then you solve. But there's different ways to do it, but this one is more straightforward, and everyone always do it this way. If y is solved already, so you don't have to do the adding, subtracting method, or elimination they call it, right? So you might remember those terms. This is substitution. This is called substitution. Always when it's y by itself. All right, solve for x, subtract x, add two. Simultaneous work here. So you're left with 6 here and 4x here. Divide both sides by 4. So x equals 6 over 4. Reduce that 3 halves. So that should be the answer for x. You're not done. So I don't know. You want to kind of bubble that or something. And then you have to, or in a coordinate form, you want to write it. I'll even write the label for that x comma y. You can write the answer. Normally they do that. The x already got 3 halves. Then you have to solve for y. So plug it back in. It doesn't matter which equation. I'll plug it in here because, it's kind of smaller. So, but you still have to combine it. 3 plus 4. Do common denominator. You can do a 1 and 1/2 plus 4, which is the answer is 5 and 1/2. If you want a mixed number, you could. That's fastest. Could you see it? Like this is 1 and 1/2, just plus 4. It's 5 and 1/2. You can do that. People will do that all the time. But when you're here in algebra too, they tend to actually have you write the answer in proper fraction, but it's not mandatory, dude. You can do it however you want. So what is that? 8 plus 3, 11 halves. But it's the same thing as 5 and a half. So 11 halves. So kind of match the improper fraction here, Yeah. So check that. Double check the math there, but I think it's good. Okay. Continue on. That's your x. This is your y. Your x, your y. Okay, for this one, man, I would not do elimination because there's nothing that kind of like you could make them. You could multiply both sides by 2, but let's don't do that. Here's why. You'll be doing it here. Let's do elimination or addition method here. But this one, I would still substitute because y is solved. I would put this whole thing in right there. So here's how it would look. It'll be 4x minus 2, parenthesis, 2x, and with the fraction even. No kidding. It looks awkward, but watch when you distribute, it'll be good. That equals 3. So this is, I'm pretty sure they intended for you to do it this way. Substitution. Okay, continue. Distribute the negative 2. So 4x stays 4x. It'll be plus 4x. Negative times negative is a positive to a fraction, but the 2 will cancel on the bottom. I hope you can see that. It'll be 3 left. You want to see it? Negative 2 times negative 3 halves. Distributing it. Negative become positive, but 2 cancel. So you just left with just 3. Could you see it like that?
Mm-hmm.
There's 2 right here. You can do the work on the side here. Yeah, so 2 cancel. You just left with 3. Double check, yeah. Positive. Negative times the negative. Negative 2 times the negative 3 halves equals 3. Okay, continue from here. Well, the answer is awkward. Subtract both sides by 3. You get 0. And the answer will be 0. Yeah, it will be 0. There's nothing you can do here. 8x divided both sides by 8 is still going to be 0.
Mm-hmm.
So x is equal to 0. So I'll put it x comma y here. 0 and then solve for y. So plug in for y. The easiest one is here again. So y is equals to negative 2 times 0, which is 0, minus 3 halves. So the answer is just 3 halves. So y is negative 3 halves. I think that's it for that one. Now, we can always come back and check it, but I want to cover as much. Checking it by plugging them back, and check both equations, Actually, I'm going to eye that right now. If I put 0 in for wait, x, I put in 0 for x. Yeah, the answer is y to 3 halves. Yeah, it looks good. This one is right. You only need to check one. Normally, the other one's automatic, like 99%. Okay, so this one, here we go. We're going to do elimination. I think you might remember. The best number to do is negative 4. So multiply the second equation by negative 4. So here we go. It would turn this into, I'm arrowing this, but it's really double arrow to be correct. If I do this in college with just the arrow, I will be wrong. Don't worry about this stuff. It's called if and only if. You bring the whole equation over, you have to have the 2 arrows like this, and the inside is like 2 bars. It's a notation that in math that they use. You can do 1 bar if you want like that. It's called if and only if. Had it been just equal to something else, equals to something else, you just put the arrow. But anyway, I'm bringing the whole equation over, so you have to use that symbol in advanced math. If you graduate, in math you have to use that. So distribute the negative 4, negative 8x minus 4y. Yeah, I do this to get rid of the y. I think you can tell.
Yeah.
And then negative 24.
Mm.
Okay, and then combine them. I'll put the bar like this. Add them straight down. That's going to give you a negative 5x here equals, what is that?
Negative 15.
Is that right? Yes, negative 15. Okay, very good. And divide both sides by negative 5. So x equals 3. Okay, for now. So you can plug it in wherever you want here, but right now I'll go ahead and put it 3 and then solve for y. So like x comma y here. Okay, so 3 is there. Now I would solve for y here, the original. Now don't do the one that you modified or multiplied by negative 4. I would do it here. So the second equation of the original, so I'll plug it in for x. So it becomes 2 times 3 plus y equals 6. I'll parenthesize it. So it'll be 6 plus y equals 6. So you subtract both sides by 6, it'll be 0. 0. So that's it. So let me kind of check it by eyeing it. Put 3 in the x, 6. Yep, that's true for the second equation. What about for the first equation? But normally, you don't need to do both equations when you check it. So 3 times 3 is 9. 9 times 0, 9 plus 0 is 9. Yeah, that's it. No, it's correct. All right. All right, moving on. Piecewise. Okay. So a lot of people, don't like this, but it's not that bad. You just need to account for the condition or the restriction here. You only use this right here if your x is less than or equals to negative 3. You only use this here if it's between negative 3 and 1, not including the negative 3 and 1. You will use this if and only if x equals to 1 or greater. Imagine that. Okay, so here we go. You see how I look at it, right? So when you ask to find this right here, this is x. Every time it's written it's like f of x. Therefore, x is negative 5. So where do you plug it in? You'll plug it in. The negative 5 is actually within this particular condition, right? It's less than negative 3. Is that right? Yeah, it's over there. Negative 5 is over there and negative 3 with the arrow. So that means you'll plug this one in right here. I hope you're okay. So here's the math that you do. Negative 5 minus 5. So number 6. So it's negative 10 minus 5. So the answer is negative 15 for 6. Okay. And then 7. X equals to 1. So x equals to 1. So right here, because the bar says you can do x equals to 1. So we'll be using that one. So it's going to be negative 3 times 1 plus 7. So negative 3 plus 7. So it should be 4 for number 7. Okay. And then f of 6, x equals 6. So 6 is what? You're going to use this again because it's where it's greater than or equals to 1 right here. So you don't use this one at all. Now, had it says something like f of 0, the answer is 4 immediately. F of negative 1, answer is 4 immediately. Is that okay? F of negative 1. F of 0.5. F of 0.5 is right between here. It's still going to be 4. You're not doing any math. Just write the y being that. But anyway, for 6, you're going to use this one again because it's x greater than or equals to 1, 6. So 3 times 6 plus 7. So negative 18 plus 7. The answer is negative 11. There you go. Right, nice. Okay, now 9. 9 is also piecewise based on the graph, but it's just graph and it's not written in the function notation. So, all right, let's see what we do here. Okay, easy. Use the piecewise function, the graph, right here. Use the graph to answer these here. All right, so again, anything in between the parentheses, it's x, x, x. Okay, so right now, for number 9, x equals negative 2. So basically what it's asking here is that when your x is negative 2, what is your f of x, which is your y? So the whole thing is y, the whole thing is y, the whole thing is y, but x is negative 2, x is 4, x is 7. I hope you're okay with that. So if you wonder, how to interpret it, it's for number 9, it's like this. When x is negative 2, y equals what? Or your f of x equals what? Or f of negative 2, basically. But I'll do f of x. So it's because you guys are used to that. So, okay, in the graph, locate negative 2 for x. So negative 2 is right here, it looks to me. So I think they're going by ones. So what is that? Well, this one is open. You cannot use it. But it ends right here. It doesn't have arrow. If it has arrow, then you can't answer that. Actually, you can. I'm sorry. If it continue, you can. But right now, to me, it's actually stopped right there. So your y is 4. Do you see it?
Yeah.
When your x is, it looks like 1/2. No, I don't mean to write 1/2. When your x is negative 2 here, your y is 4. So it's 4 here. So yeah, the answer is 4. Okay, and then when x is 4, we're doing this one. When x is 4, what is your y? Okay, 4 is here. Your y is 0. Is that okay? It's right here. It's like the graph that looks like that. So it's 0. The y is 0. Okay, when x is 7, what is your y? So 1, 2, 3, 4, 5, 6, 7. So the 7's right here. So your y is right here. So your y is negative 3. Is that okay? Negative 3. So I'm pretty sure. Let me count the 7 again. 1, 2, 3, 4, 5, 6, 7. Yeah. The 7's right there. The y is right here. I don't know why I put the circle above 7. It's just the mark. Okay. Okay, that's it. I think you're okay. Now, this one is different. Yeah, that's why I wrote this thing right here to interpret, to help you interpret the notation. Yeah. When you see this notation, it's asking, what is your y when your x is negative 2 or 4 or 7? But this time for 12, it's asking, find x when your y, remember f of x is y, that's why I wrote the f of x like that. Your f of x is your y. So find x when your y is equals to negative 1. Same thing. Is that okay? That's it. So you locate the y being negative 1 in the graph. So negative 1, like you look at the y value, y, right? So you look for the y being negative 1. Negative 1 is right here. But the line exists right here. See, I'm pointing the arrow right there.
Yeah.
Nowhere else. So the y being negative 1 right here, your x exists on the line right here. So the answer is 3. You see that? X being 3. That's it. So the answer is 3. All right, this problem. There's a rule for absolute value. So here we go. I'll write the rule here for an absolute value problem. There's a rule. The K is like the number. You can even write the number pound symbol in place of it. But they always write some kind of variable, K, A, or B here. But I'll use K. It's actually most common. So if you ever see an absolute value equation that looks like this, you have to set it. You have to write two setup coming out of it. So it come out like this. One is X equals to K, and then the word or, then X equals to negative K. So those are the rule coming from here. Like, yeah, the property, or you can think it. So they're all together here. So here we go. Let's do this one. So X doesn't mean just X. Anything inside between the bars, you extract it and you write it like this for the first equation. 14. And then the second equation, you can put the word or, you have to. If you were doing this, you have to use the word or now. Well, as before, you guys probably put a comma. So this one, the next one, it would just be a negative 14, but you still copy what's between the bars as is. Now, this can be different, but this is actually very common. This is like the most common way of writing out what you need to do next. Now, another way is very messy, okay? They can write this as plus or minus, and the 14 stay 14. Plus or minus means that you plus or minus in front of the parenthesis. You have to parenthesize it. But it'll give you the same answer if you think about it, okay? If you distribute the negative in, but I don't recommend it. You just multiply both sides by plus or minus. It will give you the plus or minus for 14, you see? But promise, this is most common. They split them into two, copy the original as is in between the bars, and then do a plus 1 and the minus 1, then solve each one separately. So you have two answers coming, and the or is split between. So continue, add 36 to both sides. You solve two, basically you do two problems in one for this absolute value equation. So 2x equals 50, yeah. Then divide both sides by 2, so the first part, x equals 25. And then or, add both sides by 36. 2x, what is that? 22, double check there. Yeah. Then divide both sides by x equals to 11. So this is it. I recommend you write them x equals 25 or x equals 11. Don't do x equals 25 comma 11. That's not correct, because you're doing the or concept and concept, so you cannot do that anymore. You cannot put a comma in between. Yeah, not like before. Yeah. So you got to do that with the word or. Okay, same thing with this one. Oh, but there's something easy coming here. So this is a special one. So make sure you look for this on the test and the quiz. I think they'll make one like it, at least one. So anyway, continue with this. You want to kind of isolate the absolute value so it looks like this, so that the number is kind of all by itself on the other side of the equation. So you want to make this look like that. So you just subtract both sides by 7. So that the number is all on the other side. So negative 5 here. And then copy down the absolute. Yeah, don't need anything fancy just yet. So the Q, this is my Q, looks like that. And 3, absolute value, bar still. Okay, right here. This is where you probably don't even need to write this. None of these here. What you need to at least kind of like acknowledge is that if you mentally subtract both sides by 7, and this side happens to be a negative, there's no answer. So think about it, like absolute value of anything will never be a negative number. All you do is like slash through and then say empty set. I think they use empty set or no answer or something, no solution. So there. So it doesn't matter if it's Q, X, Y, or Z. So absolute value of anything inside equals a negative number is not possible, right? Because, like you always been taught that whatever you put in there, the absolute value, make it a positive number. That's why this does not work. So yeah, make a note. This is going to be on the test. I think at least one problem. So look out for it. It's always like that. Okay, this one, same thing. You want to isolate the absolute value on one side, whatever's inside, and a number on the other side. So it looks like this right here. That right here. So So the 8 is in the way. So divide both sides by 8 to get rid of it. Then you're left with the absolute value of b minus 3. What is that? 6? Wait. I've been doing this for a long time. Extensive number of hours. What is that? 8 going to 64. How many times? 8 times, right?
Yeah.
Okay. Right. Continue from here. Now we're going to do the same thing like we did here. You can split them into 2 equations, one and with the or in between. So the first one, the 8 stay as is, and the 2b minus 3 as is. This might be equals 8. And the other one is 2b minus 3 equals negative 8. So this is most common. This is the most common, easy, clean way of continuing on or setup. Right? Do one at a time first. So 2b equals 11. So b equals 11 halves here. So that's one part with the or coming up. Oh yeah, when you answer them, I think you want to bubble them together. Yeah, I forgot to.
Yeah.
Let me not bubble this one. And the or, right? Add both sides by 3. 2b equals negative 5. Divide both sides by 2. You're left with negative 5 over 2. So here's the answer together. Okay. Right. Are we okay with that? Moving on. Without a calculator, simplify the radical. Okay. All right. Now, I don't know on top of my head what is the biggest number that is a factor of 324. So I normally just go ahead and half it, and half it when it's even. So yeah, sometimes I catch it. I don't recognize this number. So let's half that. Half of 300 is 150. Half of 20 is 10. Half of 4 is 2. So half of 324 is 162. So I'll do 2 times 162. Sometimes you get a perfect square number out of it right away, but not yet in this case. Double check. Yeah, so 162. So half this again. Half of 100 is 50. Half of 60 is 30. Half of 2 is 1. So add them up. So it's 81. Okay, we got it. We got the perfect square right here. Is that right? 81. Yeah. So 81 twice gives you that. See, I never actually, I'm doing this for a long time. I still actually never kind of like recognize the 162 being twice 81. I should, but no. Yeah. Okay, you can stop here, but you could continue 9 and 9, right? You can do that, but I think you might like it this way. Is something like this. The next step should be something like this. This is really up to you, okay? Anytime you see when you prime factorize, every time you see a pair of number that you factor it out, it comes outside once already. But I'll make it neat here. I'll go ahead and it's equals to 4 times 81. You see how I got it? It's 4 and 81. So therefore, the 4 happened to be a perfect square number, and 81 is happened to be a perfect square number. Therefore, it's a 2 coming outside. It's like you split them into 2 roots. A root of 4 times the root of 81. Therefore, it's a 2 times 9. So the answer is going to be 18. So I never actually remember this. I believe like maybe last year or year or even this year, you guys may be given, or year before, I'm sorry, like 3, it could go back as 2 years back. You may be given like a list of perfect square number up to like 20 or even 30. So 18 times 18 is actually 324. I don't remember that, dude. I'm sorry. Here, watch. 18 times 18. I never, yeah, there is 324. I would not remember that. You don't need to remember that because that's not a common number you're going to use. That's why. In 19, same thing. I would half it. 75, 2 times 75. Now from here, double check, yeah, 2 times 75. Yeah. From here though, you might remember that this is like 3/4. So it's the same thing as 3 times 25. So I would stop right here. When I come across a perfect square number, I would immediately stop. So it's really the same thing as this, if you wonder. If you organize it like this, it's nice. Like you circle when you factor, the 2 is the only even prime number. once you actually come across prime numbers and a perfect square, you might want to stop, and then you could list it in the root. So it's like 2 times 3 times 25, like that. So that means the only thing that can come out is a root. It's the same thing as root 25, by the way, you split them. A root of 6 and a root of 25. So therefore 5 comes out, and the only thing you have left is 6. So this is final answer. Do you remember? Okay, you remember something about it like that? Yeah. Okay, this one. Now, I believe you've done imaginary numbers, right? So therefore,
Yeah.
let's set it up to continue. So this one is automatically I root 169. So you have a negative. So if you want to see the actual step by step, it's really the same thing as a root of negative 1 times the root of 169. But if you recall, the root of negative 1 is I. So there it is. So I immediately go to this step right away. And then I continue with this. But this one I do recognize. It's 13 times 13. So it's really equals to 169. So the answer is going to be 13i. A root of 169 is 13. So it's 13i. So let me double check that. Pretty sure. There it is, 169. The root of 13 is 169. The I, so I switch them around. I 13, I do 13i because they treat I as like the variable, like 13x. So they tend to do that. Okay, this one, same thing. I'll do an I root 245, and then I'll deal with the root 245 separately. So the I will stay with all the steps here in the steps. So, but let's do 245 prime factorize here. I know it's divisible by 5. So how many times? 49, I think. Okay, then we can stop there because we got a perfect square number right away. But let me check. 5 times 49. Yeah, 245. So that means you can now show the work this way. Same thing I did before. It's the same thing as 5 times 49 inside the root. Therefore, the root, don't forget, it's the same thing as root 5 times root 49. If you were to split it. But the I is still in front. But anyway, I just want you to see what I see in my head here. Root 5 times root 49. So it's going to be 7i root 5. Yeah, they squeeze the I in between there. But you can put it in the back if you want. But this is standard arrangement.
Yeah.
There you go. I hope you're okay with that. That's not bad. Okay, back to the power thing, if you recall. So all you do is just divide it by 4. The remainder is the answer. So the remainder is the remainder is the exponent of the I in the answer. I'll write it out. Even 0, everything. Watch. Let's see. 4 going to 9, 2 times 8. Subtract, you get, yeah. Yeah, you don't have to show all the work. I think I don't need to show you the expansion work here. Just write. Your teacher will accept it. You've done this before. So 1 and then bring down the 9. What is it? 4 times 6. So here it is. The remainder is 4. So what you do is that you write equals to I to the 4th power. Then you have to evaluate that. So it's really the remainder. The remainder is your I to the remainder. The answer is I to remainder. So the remainder is 4. Double check. Oh, 3.
I think
Sorry. 3. Sorry. Yeah. So 3 here. So I to the 3rd. But let's list all the I component here. So here we go. The first thing is that you can keep the I when you see it. You don't want to write a root of -1, but the I squared, you have to write as -1. I to the 3rd is negative I to the 4th is going to be 1. So you can copy this down again if you need to. So you're only allowed to write I, -1, negative I, or 1. So this here, the remainder is always the I to the remainder is the answer. But based on the list here, the final answer is -1. Oh, negative I, sorry. This is my negative I. This is my negative I here. So the answer is -I. You're allowed to keep. Okay, let's do the same for here. So 4 divided by, I'm sorry, 33 divided by 4. 7. Yeah, no, 8, sorry. 32. So the remainder is 1. So that means I to, the next step from here is I to the 1. So the answer is just I. Yeah, I. I to the 1 is I. So you're allowed to keep I, -1, -I, and 1. So there's your answer. That's what the answer, that one. Okay, this one, same thing. 4 into 252. 6 times 24. Subtract 1, bring down to 2. 3 times. So this goes into it evenly, but don't worry. The remainder is 0. You complete the whole division. So then you write I to the 0 power. Anything to the 0 power, it's 1. There you go. But still 0 power here. 1. There you go.